All right, let's dive right in. We're going to talk about a powerful operating model that's really changing the game for managing cloud-native systems. Think of this as your practical architect's guide to GitOps on AWS.
So here's what we're going to cover. We'll kick things off with the core promise of GitOps. Then we'll get into its main principles. After that, we'll see it in action, figure out how it plays with the tools you're probably already using, and wrap up by helping you decide when this is the right move for your projects. As architects, we see it all the time. Our systems on the cloud, they grow, and so does their complexity. Honestly, just managing the state of it all becomes one of our biggest battles. So let's just start with a really powerful idea. What if you could build a system that was so resilient it actually fought back against unauthorized changes and just automatically fixed itself to match what you designed? This idea, it really goes after a silent threat that haunts every single production environment. Configuration drift. You know what I'm talking about. It's that slow, creeping mismatch that happens over time where what's actually running is no longer what's in your code. That drift, that's where instability and those "well, it works on my machine" mysteries are born. Okay, so how do we fight this drift? Well, the answer is all about establishing one single, undeniable source of truth for what our system is supposed to look like. And that brings us right to the heart of GitOps. At its core, GitOps is an operating model that makes one very simple rule. Git is the only source of truth. That's it. It means every single piece of your system, every deployment, every service, every config map is all defined declaratively, and it all lives in a Git repository. And this is absolutely the best way to visualize it. Your Git repository is now the master blueprint for everything. Then you've got this tireless little agent, a reconciler, running inside your cluster. And its only job is to constantly look at the blueprint in Git, then look at the reality in the cluster, and immediately fix anything that doesn't match. This really highlights the huge shift in thinking. In the old push model, your CI server, like Jenkins, basically held the keys to the kingdom. It had to have credentials to push changes straight into your production Kubernetes cluster. But with the GitOps pull model, everything is flipped. The cluster pulls its own updates. That agent inside the cluster reaches out to Git, sees a difference, and pulls in the changes itself. It's way more secure, and it gives the cluster autonomy. Okay, so that's the theory. But what does this look like in the real world? Let's actually trace a change from a developer's first keystroke all the way to production. So for our example, let's picture our setup. We've got an Amazon EKS cluster, and inside we're running one of the big name GitOps agents, something like Argo CD or Flux. That agent is already up and running, just sitting there watching our Git repository. So check out this flow. A developer changes a Kubernetes manifest. Let's say they just update a container image version, and they push that commit. The agent, which is always watching, sees that new commit instantly. It then pulls down the updated manifest and applies it to the cluster. And just like that, the running state of the cluster now perfectly mirrors what's in Git. No one had to lift a finger. But this is where it really feels like magic. So let's say that new image had a bug. What's the fix? It's not some panicked late-night session trying to cube control your way out of trouble. No, it's a simple, safe git revert. The second that revert commit gets pushed, the agent sees it and automatically rolls the entire cluster back to the last known good state. Your Git history is your operations playbook. And what about that configuration drift we were so worried about? Well, imagine someone goes rogue and uses kubectl to manually scale a deployment. The reconciler sees this. It sees a deviation from the blueprint in Git. And within moments, it automatically reverts the change, forcing the cluster back into compliance with the source of truth. It's a self-healing system, for real. Okay, this brings us to a super important strategic question for any architect who's thinking about this model. How on earth does GitOps fit in with the infrastructure as code tools that we already know and love? Right. This is the question that always comes up. This sounds great, but I use Terraform for everything. Does GitOps replace it? And the answer is a very clear no. They're actually meant to work together beautifully. This table just lays it out perfectly. It's all about drawing a clear line. You use your heavy-duty IAC tools like Terraform or CloudFormation for the foundational infrastructure. Provisioning the VPC, the EKS cluster itself, the essential IAM roles, your databases. But for everything inside the cluster, the apps, their deployments, services, configs, that becomes the job of GitOps. It's like one tool builds the house and the other furnishes the rooms. So here's the key takeaway for you, the architect.
This separation doesn't just happen on its own. It's a deliberate design decision. It's your job to structure your repositories in a way that reflects this boundary, creating a really clean separation of concerns between your infrastructure code and your application configs.
All right, let's get to our final section and put together a simple framework. How do you actually know if GitOps is the right move for your specific project? Here's a pretty good rule of thumb. GitOps is an absolute slam dunk for Kubernetes native workloads, especially on a service like EKS. It's amazing for any environment where you need a rock-solid audit trail, because your Git history is your audit log. And it really, really shines when you're managing complex microservice ops with a ton of moving parts and tons of deployments. But on the other hand, if your world is mostly VM-based or heavily serverless with things like AWS Lambda, GitOps might be overkill. Other models might just fit a little more naturally there. And this quote really just nails it. GitOps isn't some kind of silver bullet for everything. Its value absolutely skyrockets when you can describe your system's entire desired state declaratively, right there in code. The more declarative your world is, the more powerful GitOps becomes. So I'm going to leave you with one final thought to take back to your team. You know, moving to GitOps is as much a cultural shift as it is a technical one. So if your Git history truly becomes the single source of truth, the one definitive log of every change ever made, how does that change something as simple as how you write a commit message? What kind of information would you need in there? Something to think about. Thanks so much for tuning in.